In the last segment, we talked about the periodic table as being divided into groups and periods. Members of a group are similar, whereas members of a period are not necessarily similar in the same way. This segment, we're going to talk about the fundamental difference between an atom and an element. Now, it's not unlike, for example, a group of pencils. These are all pencils because of the way we've defined them. And yet, the pencils aren't entirely exactly the same. And we're going to explore that as we go along. I'm going to use the words sort of interchangeably, although the difference will manifest as I go along. Nonetheless, whether I have a singular atom, like my pencil, or a collection of those atoms, which I would call an element, it is defined by the number of protons. And so one way we can symbolize these is with what we call a nuclide symbol. Okay, now X simply means the element. There is no element X, where A is equal to the atomic number, which is equal to the number of protons. B is equal to the mass number, which is equal to the protons plus neutrons, because we saw on the other page that protons and neutrons add mass. C is equal to the charge, which is the positive protons plus the negative electrons will combine to give us the charge. Now our nuclide symbol, I could write, say this, all three of these have the same symbol, which make all three of these carbon. By definition, carbon has 6 protons. So all three of these are going to have 6 protons, 6 protons, 6 protons. What makes them different, however, is their mass. Mass of 12, mass of 13, mass of 14. So it's not changing of electrons that changes mass, it's changing of neutrons. So 12 minus 6, I could put the 6 down here like this, but usually and typically you don't see it written that way. It's just it's just a difficult way to write it. So usually you'll just see the number and the symbol, or just the number and a dash and a symbol. So carbon 12 has 6 neutrons. Carbon 13, however, has 7 neutrons. Carbon 14 has 8 neutrons. So the only difference between these so far is the neutrons. All of these have no number written where there is charge, which means the charge is 0. The number of protons plus the negative electrons will have to equal 0. So if I have 6 pluses, how many minuses do I need to make that equal 0? And the answer is 6. All of these have a neutral charge, and therefore all of them will have 6 electrons. The collection of carbons here is not entirely unlike my collection of pencils. They're all carbons, but they're slightly different. And the difference is the mass. And this collection is what we're going to call isotopes. These are isotopes. Iso is a prefix that means the same. So it's the same element, but what's different about it is that they have different masses. Okay? If I try a collection like this, all of these are given the symbol H, which is hydrogen. Hydrogen, hydrogen, hydrogen. Okay, and you look at your periodic table and you will see that hydrogen has 1 proton. So all of these are going to have one proton, one proton, one proton. The difference will be in the mass. So it's not the protons that change the mass, it's the neutrons. If I have a mass of 3 minus 1 proton, I'm going to have 2 neutrons in hydrogen 3. 2 minus 1 is 1 neutron in hydrogen 2, and 0 neutrons in hydrogen 1. The electrons, in either scenario, there's no charge. So 0 equals the number of protons plus the number of electrons, which are negative. 0 equals 1 positive for the proton, plus how many negatives do I need to make that 0? And the answer is that all of these will have 1 electron, 1 electron, 1 electron. So again, the only difference between these 3 atoms of hydrogen is that one has 2 neutrons, one has 1 neutron, and one has 0 neutrons. Again, it's not unlike my analogy, which are my pencils. Pencils are pencils because of the way we define them, and yet they are slightly different. Okay? So these 3 are isotopes of each other. Okay, so these are isotopes as well. Okay? All right, let's try 23Na, 23Na plus, or plus 1. They mean the same thing. Na is sodium, so both of these atoms, if I'm talking about a singular entity, are sodium. And by definition, sodium has 11 protons. Okay? They don't change mass. So these are not isotopes of each other. 23 minus 11 is 12 neutrons. 23 minus 11 is 12 neutrons. So far they have the same number of protons, the same number of neutrons. What they differ in is their charge. 0 equals 11 pluses from the protons. How many negatives do I need to make that equal to 0? Well, the answer is 11. Over here, my charge is now a plus 1, which means my 11 pluses has to be balanced with electrons so that my overall charge now is plus 1. This means there are 10 negatives. 11 plus negative 10 equals plus 1. So when I lost 1 electron, my charge became a plus 1. Okay? Let's try down here. 27Al, 27Al plus 3. My phone. Okay, so Al is aluminum, so they're both aluminum. Both of them have 13 protons. Both have the same mass. 27 minus 13 is 14 neutrons, 14 neutrons. But the difference is I have to lose electrons in order to get a plus 3 charge. So my charge here on this one is 0. So I have 13 pluses. I need 13 minuses to make that equal 0. 13 electrons. Electrons are negative. Okay? On this one, I need a plus 3. So some number plus 13 has to equal positive 3. 10 electrons. 10 electrons. There's going to be something specific about these numbers that I will describe as we go along. When we lose electrons, we get positive charge. when we lose electrons, we get positive charge.